Shiwalik Range. Formation of Himalayas in CC Convergence. Siwalik Range. Siwalik Range, also known as Siwalik Hills or the Outer Himalayas, Siwalik, usually written Shiwalik, is a sub-Himalayan range in northern India. It stretches over more than 1,000 miles, 1,600 kilometers, west-northwest from the Tista River in Sikkim state, northeastern India, across Nepal, northwestern India, and northern Pakistan. The Siwalik are sometimes thought to encompass the southern Assam Himalayan foothills, which continue eastward for 400 miles, 640 kilometers, over southern Bhutan to the Brahmaputra River bend. The range in which the name is called Siwalik, from Sanskrit, meaning, belonging to, the god, Shiva, is the 200 miles, 320 kilometers, of foothills in India running northwestward from the Ganges River in Haridwar, Uttarakhand state, to the Beas River. Outer Himalayas or Shiwalik. Despite being only 10 miles, 16 kilometers, broad in some parts, the range has an average elevation of 3,000 to 4,000 feet, 900 to 1,200 meters. It rises abruptly from the Indus and Ganges, Ganga, river plains in the south and follows the main range of the Himalayas in the north, divided by valleys. The southern slopes of the Shiwalik mountain in Punjab and Himachal Pradesh are densely forested. Chos, or seasonal streams, cut deep into the highlands. Valleys are synclines, whereas hills are anticlines or anti-synclines. In the south, we call them the Shiwaliks, and in the north, it is called the Greater Himalayas. When it runs nearly parallel to both ranges, it is often called the Himachal or Lower Himalaya. Shiwaliks were the final ranges to develop, 2–20 million years ago. These deposits were folded and hardened as a result of the compression provided by the Indian plate's northward migration. The Shiwaliks are consolidated sand, gravel, and conglomerate deposits carried by rivers, flows flowing from higher elevations. Conglomerates accumulated to produce the Shiwalik Hills, sand, stone, silt, gravel, debris, etc. Importance of Outer Himalayas or Shiwaliks. The importance of Shiwalik ranges is as follows. Shiwalik ranges which are present in northeast India to that of Nepal are forested densely, but there is a decrease in forest cover from the west of Nepal. The southern slope of the Shiwalik ranges in Punjab and Himachal Pradesh are almost devoid of any forest cover. Valleys are part of synclines and hills are part of anticlines. Siwalik Mountains are sometimes thought to include the southern hills of Assam Himalayas and extend 400 miles across southern Bhutan to the Brahmaputra River. These sections are made of uncoordinated rivers and dense alluvium rocks cover the valleys. Important duns include Dehradun, Kotli Dun, and Potli Dun. Convergent boundary. Along a convergent boundary two lithospheric plates collide against each other. When one of the plates is an oceanic plate, it gets embedded in the softer asthenosphere of the continental plate, and as a result, trenches are formed at the zone of subduction. Convergent boundary. In convergence there are subtypes, namely collision of oceanic plates or ocean-ocean convergence, formation of volcanic island arcs. Collision of continental and oceanic plates or ocean-continent convergence, formation of continental arcs and fold mountains. Collision of continental plates or continent-continent convergence, formation of fold mountains. Collision of continent and arc, or continent-arc convergence. Continent-continent convergence or the Himalayan convergence. Understanding continent-continent convergence is important to understand the formation of the Himalayas, the Alps, the Urals and the Atlas Mountains. In ocean-ocean convergence and continent-ocean convergence, at least one of the plates is denser and hence the subduction zone is quite deep, few hundred kilometers. In continent-continent convergence, at continent-continent convergent margins, due to lower density, both of the continental crustal plates are too light, buoyant, to be carried downward, subduct, into a trench. In most cases, neither plate subducts or even if one of the plates subducts, the subduction zone will not go deeper than 40 to 50 kilometers. The two plates converge, buckle up, suture zone, fold, and fault. As the continental plates converge, the ocean basic or a sedimentary basin, geoclinal or geosynclinal sediments found along the continental margins, is squeezed between the two converging plates. Huge slivers of rock, many kilometers wide, are thrust on top of one another, forming a towering mountain range. With the building up of resistance, convergence comes to an end. The mountain belt erodes, and this is followed by isostatic adjustment. As two massive continents weld, a single large continental mass joined by a mountain range is produced. Examples: the Himalayas, Alps, Urals, Appalachians, and the Atlas Mountains. Formation of the Himalayas and the Tibetan Plateau due to continent-continent convergence. The Himalayas are the youngest mountain chain in the world. Himalayan mountains have come out of a great geosyncline called the Tethys Sea, and that the uplift has taken place in different phases. During Permian period, 250 million years ago, there was a supercontinent known as Pangaea. Its northern part consisted of the present-day North America and Eurasia, Europe and Asia, which is called as Laurasia or Angaraland or Laurentia. The southern part of Pangaea consisted of present-day South America, Africa, South India, Australia and Antarctica. This landmass was called Gondwanaland. In between Laurasia and Gondwanaland, there was a long, narrow and shallow sea known as the Tethys Sea. All this was explained earlier in continental drift theory. There were many rivers which were flowing into the Tethys Sea. Some of the Himalayan rivers were older than the Himalayas themselves. We will study this in antecedent and subsequent drainage. Sediments were brought by these rivers and were deposited on the floor of the Tethys Sea. These sediments were subjected to powerful compression due to the northward movement of the Indian plate. This resulted in the folding of sediments. An often cited fact used to illustrate this process is that the summit of Mount Everest is made of marine limestone from this ancient ocean. Phases of formation. The Himalayas do not comprise a single range but a series of at least 3 ranges running more or less parallel to one another. Therefore, the Himalayas are supposed to have emerged out of the Himalayan geosyncline, i.e. the Tethys Sea, in 3 different phases following one after the other. The first phase commenced about 50 to 40 million years ago when the Great Himalayas were formed. The formation of the Great Himalayas was completed about 30 million years ago. The second phase took place about 25 to 30 million years ago when the Middle Himalayas were formed. Shiwaliks were formed in the last phase of the Himalayan orogeny, say about 2 million to 20 million years ago. Some of the fossil formations found in the Shiwalik Hills are also available in the Tibet Plateau. It indicates that the past climate of the Tibet Plateau was somewhat similar to the climate of the Shiwalik Hills. Formation of Alps, Urals, Appalachians and the Atlas Mountains. The formation of each of these mountains is similar to the formation of the Himalayas. The Alps are young fold mountains which were formed due to the collision between African plate and the Eurasian plate. The Atlas Mountains are also young folded mountains which are still in the process of formation. They are also formed due to the collision between African plate and the Eurasian plate. The Urals are very old fold mountains which were formed even before the breakup of Pangaea. They were formed due to the collision between Europe and Asia. The Appalachians are also very old fold mountains which were formed even before the breakup of Pangaea. They were formed due to the collision between North America and Europe. Volcanism and earthquakes in continent-continent convergence. Oceanic crust is only 5 to 30 kilometers thick. But the continental crust is 50 to 70 kilometers thick. Magma cannot penetrate this thick crust, so there are no volcanoes, although the magma stays in the crust. Metamorphic rocks are common because of the stress the continental crust experiences. With enormous slabs of crust smashing together, continent-continent collisions bring on numerous and large earthquakes in Himalayan and North Indian region, Kutch region. Thank you.